Okay, hello. For our reaction of crystal violet, we're going to react at one temperature, at room temperature. It's about 19.7, and at the time of our lab, we'll take that temperature and we'll mix it. And we will have a graph of absorbance versus time using our colorimeter. So I'm getting it calibrated right now. It's at 0. We'll take that data, put it in Excel, and then see what kind of graphs will be linear. So we're doing it at room temperature over there, and I've got a cool water bath. Right now it's about 7.3 Celsius, and I just put these together. So I've got some crystal violet, I've got some sodium hydroxide, and in about 15 minutes we'll do the reaction. Also, I wanted to do this for a long time, just to have a visual of what happens. Every time we do the lab, we take the measurements and then say, oh yeah, I got lighter. So here's the beginning, some crystal violet with some, instead of sodium hydroxide, I just put distilled water to see what color it would be. And then we tried out the lab. I tried it out with some, just make sure it would react correctly, and that's the color it turned out to be. So I'm going to timer it, and I'll have a video of the time. In addition, I've always wanted to do it, is we find the order of crystal violet by using the graphing of concentration, which is proportional to absorbance. So we read the absorbance, and the graph of absorbance versus time tells us what order it is. But this year, we usually use 0.1 molar sodium hydroxide. I made a second container of 0.2 molar sodium hydroxide. So we're going to talk about the rate, and I'll take data on it and see how that works. Ideally, I would do like 3 or 4 experiments to do the method of initial rates, but this time I'm just going to do 1 sodium hydroxide at 0.10 and 1 sodium hydroxide at 0.20. So we'll see how that works. So there's the warm temperature. We'll see how it compares visually. And I did 6 minutes for the other ones, so we'll see what 3 or 4 minutes looks like.